Hi everyone, it is that time of the year again where we prepare for Waec physics practical. Now in this video, it is going to be one of the series of the numerous videos that we are going to do for preparation for the Waec physics practical proper. Based on the materials that we could lay our hands on, we should be expecting experiments on a spiral or a helical spring, and one on the principle of moment, that is moment on a metal rule. So you should be expecting either this or that for mechanics. Then in the aspect of optics, you should also expect one of two experiments. We will discuss that in subsequent video so that we don't bore you with too many talks. Then we'll go over to electricity as usual. For today's video, I am going to perform this experiment. Then afterward, I will also teach you a way to find your way around manipulating the result without carrying out the experiment. So I'll look for a very short and faster way for you to get your readings and then plot your graph so that you don't waste much time on that. Without much ado, we'll kick off with the practical. We'll just read through the questions and carry out the experiment. But before I start that, let me quickly use this medium to wish all of you that are sitting for this Waec a very successful Waec examination. And at the end of the day, you all will come out with flying colors for the efforts that you have all put in. And please don't forget, if you find this video very interesting, please hit the like button, subscribe, and you can also share with your friends so that they can also benefit from what we are doing here. Okay, let us quickly run through this. We have a setup, so I'll read through this. You have been provided with a retort stand, clamp and a bus, a set of masses, a spiral spring, this could also be called a helical spring, stopwatch, split cork, and other necessary apparatus. Using the diagram above as a guide, this diagram here, carry out the following instructions. 1. Suspend the spiral spring vertically as shown in the diagram. You can see it here. Suspend a mass hanger on the free end of the spiral spring and add a mass M equals 50.0 gram to the hanger. Pull the hanger gently downwards and release to set it into vertical oscillation. Determine the time T for 20 complete oscillations. Evaluate the period of the oscillation. Also evaluate T squared. In fact, here, what I want to do is this. As I'm reading through this, I'm going to draw a set of table for my readings. As I'm reading through it, I already know what they want me to do. So the first thing I have to do is what? To suspend a mass hanger on the free end of the spiral spring and add a mass, M is equal to 50 grams. So there's going to be a column for mass. Let me just put that there, mass in grams. Then I have to set that into oscillation. So I've determined the time T for 20 complete oscillation. So there's going to be T there, measured in seconds. The time is measured in seconds. Then we have to evaluate the period of the oscillation. So the period T of the oscillation should be here. So we evaluate the period T. So here, there's going to be T, and the period is given as small t divided by the number of oscillations, that's 20. So we have in seconds. Then we have to evaluate T squared. So these are the what are required for us. So this is going to be in second squared. So this is the required table. So once you have your table like this, what you just have to do is to fix all the values into this. Then you start taking your what reading without going back to this, to the questions, to be looking at the question. So I have the mass here, 50 grams. So I have 50.0. This write it this way, 50.0. I have another mass, 70.0, 90.0, 110.0, and 130.0. So they said in each case, determine T. So in all of this, we are going to determine T and evaluate T and what? T squared. So we are going to evaluate this and this also. Tabulate your reading. So this is my table. We will now go to this, plot the graph of T squared on the vertical axis against N on the horizontal axis. So we'll go to that. Let's continue with the practical. So this is what I'm going to have. This is my setup here. I have a setup here. So this is my return stand. And here, I don't have, I am not using a split cork. So I'm placing this here. So what I'm going to do, I'll take my slotted masses. These are my slotted masses. They come in different sizes. This one is 20 grams each. Then I have some. I have 50 grams on this. I have 50 grams. This is 50 grams, 50 grams, 50 grams. And the down one is 100 grams. So I need a mass hanger. So this is my mass hanger. The mass of this mass hanger is 10 grams. 10 grams, 20 grams should be enough. Should be okay. So you don't use a mass hanger that has too much of mass on it. So you can just use 10 grams. So I'll fix the mass hanger here on this. Then I'm going to fix a mass of 50 grams. This is a mass of 50 grams. I'll place it on this. Now this is my stopwatch. You can make use of a digital stopwatch, but here I have an analog stopwatch. So we set this into oscillation using a very small angle. So you can set it. You can allow it to settle down before you start counting. It doesn't necessarily that immediately you depress, you start counting. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so my reading on my stopwatch is 10.1 seconds. So I'm going to record that here. 10.1, then just 10 seconds. Let me take it to 2 decimal places. Again, the next one is 70 grams. So I'll just add 20 grams to this. Then I'll set my stopwatch. Then I'll display with a small angle of displacement. So let me allow it to settle before I'll start counting. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my time on my clock is 14.9. So I've got 14.90. 14.90. If you like, you can do it twice and take the average. So let me try and take it again as it is going. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what I got here, on taking it again, I got 11.8. So you see, when you take it that way, you will get average. You take the average. So you have to include that on this. So I have 14.90 plus 12.80. So I can take the average of this to have a better result. How do I get that? I'll just multiply them together and divide by 2. So 14.90 plus 12.8 divided by 2. Should I give you 13.85? 13.85. but you need to show it on the table if you are going to be taking the average. So you are going to have T1 and T2. You need to include this on the table. So you now have this T divided by 2. You see, okay, T is equal to T1 plus T2 divided by 2. You need to include that on the table. But you know, I'll just do this on this because I didn't include that on the table. So I'll just work it out. Next, the next mass there is 90 grams. So I'll just add another 20 grams to it. So this makes it 90 grams. So let's set into oscillation again, once again, small oscillation. So let's start counting. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what I have here is 12.1. So I'll take that again, I'll take the average, 12.1. So that I have a better accurate result. The oscillation is very fast. It is faster than that of a simple pendulum. So you need to be very careful when taking the reading. So let me take that again. As it is swinging, I can still take it. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here I have 13.0. So plus 13.0. So let me add that together and divide it by 2. So I have 12.1 plus 13 divided by 2. So I'm having 12.55. 12.55. Now from this you can see that this is greater than this. So what I have to do, let me take this again, because as the masses increases, the oscillation, the time for oscillation should be also increasing. So let me remove this and take that again for the 70 grams. So I will set this. So let me set it to small oscillation. You do not like to wobble up and down, just tap a little bit. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I have 10.1, 2, 3, 4, 5, 10.5. So I have 10.5 plus. So I'll take it again. Okay, as it is going, I can also take it again. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I have 10 points. So this is 11, 11, 0.1, 0.2, 0.3, 0.4, 0.5, 11.5. 11.5. So let me add them together and get the average. So 10.5 plus 11.5 is equal to 20. When I divide that by 2, I get 11.0. So this is much more better. 11.00. If you use a digital stop clock, you'll get the result directly. Oh, you're disturbing. Okay, next we'll go for 110. So this is 170. We've already done that. So I'll add another 20 to it. That makes it 110. Then I'll reset my stopwatch, and then I'll start all over again. So let me display it. Now you will notice that the more the weight, the slower the spring, and it gives you an opportunity to be able to determine the oscillation, count the oscillation effectively. For 50, you find out that it was very difficult for me to actually get the value because of the spring that I'm using. You may have problems like that, but not to worry. You can settle that out. Now this is still oscillating, so I can take the oscillation straight. So let me take the oscillation from there. Let me start. 1, 2, go. So 1, push. So I use my hand to touch. I have to restart it again. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here I'm having 12, 13, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 13.6. So I'll take the average of this again. So I have 13.6 plus. So let me reset this. It is still oscillating, so I can still take it like that. So let's go. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what I have here is exactly 14. So I have 14 here. So let me add them together and take the average. The average is to add them together and divide it by 2. That's the average. So I have 13.6 plus 14. That's 27.6 divided by 2. That's 13.80. So I have 13.80. So these are my readings. So finally, we go for 130. We go for 130. And we'll set this into oscillation again. Let me set it to oscillation. Okay, we can start counting. 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what I have here is 14.5. 14.5 my stop clock. So I have 14.5 0 plus. So I'll take that again. I'll reset my stop. It is still oscillating, so I can start to count when I'm ready. So let's go. 1, 2, go. 1, 2, 3, 4, 5, 6, 7. So these are my recorded value for T. So I have to evaluate T and T squared. So how do I evaluate T? My value here 10.10 from my calculator, 10.10 divided by 20. That's going to give me 0.505. Then I'll have to square that. Squared. That gives me 0.250025. So I can express this to 3 decimal places. 0.255. I'll go with this again. 11 divided by 20. That's going to give me 0.55. I have 0.55. So I just have to add 0 to this to make this to be in 3 decimal places. So I have to square this again. When I square that, that's going to give me 0.3025. So I spread that to 0.303 so that they will be in the same decimal value. So 3 decimal places. Then I have 12.55 divided by 20 again. That gives me 0.6275. But I have to express it to 3 decimal places like this. So I have 0.628. So I'm rounded out 7 to 8. Then I'll square that again. square that, so that's going to give me, okay, 0.628 squared. That's going to give me 0.3943. So that 3 is not divided, so I'll leave it at 0.3942. 3 decimal places. So I have 13.80 divided by 20 again. Divided by 20. That's going to give me 0.69. I have to add 0 to it to make it 3 decimal places. So I'll square that. That gives me 0.4761. So I'll round out to 3 decimal places, 0.476. Then I have 15.35 divided by 20. So that gives me 0.7675. 3 decimal places, I have 768. So I have to square that. 0.768 squared is equal to 0.58984. So I'll take that to 3 decimal places. That's going to be 0.590. So these are all of my readings from the experiments that I have performed. So I'm going to plot the graph of this and the result I'm going to make from the manipulation of this in my next video. So I'm going to record this down. In my next video, I'm going to show you how you're going to manipulate your values without carrying out the experiment. Then I will now go ahead and plot the graph of this and plot the graph for the other. So I'm going to plot the 2 graphs from that video.